Welcome to this session on Mastering Systems Thinking. A big thank you to the organizers of this wonderful conference and inviting me from Canada, where, when I'm not on my motorbike, I hike mountains and get bossed around by my cat. I'm a business systems analyst, requirements engineer, and project manager consultant. I have a master's in IT with a systems engineering focus, and I use systems thinking to improve projects. I'm going to talk about the application of systems thinking, and I'll stay away from too much theory and focus on practical applications of the concepts so you can have a takeaway, something that you can use in your work. If you can master systems thinking, your projects will benefit. You will benefit. What I've noticed is that people who can think in a systems thinking way get more done in less time, have fewer errors and fixes to do, have better relationships with coworkers, and are more productive. All of this leads to you being noticed more and getting more recognition, better assignments, better projects, and better jobs. So a positive feedback loop. Let's have a common baseline here. Before we get into the definition and characteristics of systems thinking, we're going to take a look at some everyday things and talk about it if they involve systems thinking or not. So let's take a look at systems thinking in action. Right now we have a picture of a line and a spider web. And intuitively, which image is an example of systems thinking? Well, the one on the left, the line. But why would you make that choice? The line is simple. It doesn't have parts. It doesn't have any interaction of parts. Systems thinking involves different kinds of parts and interactions. So good choice, choosing the one on the right, which is the web. And a spider web is a really good example of a complex system. It includes parts, so the web, the fly, the spider at a minimum, and these parts are contained within boundaries. Every system has boundaries, so the boundaries include these parts and the greater ecosystem. And this system is also adaptive because spiders might change the web design based on prey availability. So are there flies around? Maybe we need to move a web. We need to go somewhere else. The location, or even if the web is damaged and needs a rebuild. So it sounds like a software system. The fly is an input, and the output is a snack for the spider. That's the finished product. So the spider web involves non-linear interactions, emergence, which is new behavior, and adaptivity. These are the hallmarks of a complex system. So even without you even knowing about all of these things, if you're new to systems thinking, you could generally guess that the spider web was an example of systems thinking. In your workplace, thinking about problems in terms of interactions among parts and boundaries helps you solve problems. If somebody gives you bad information, is the root cause traced back to that person, the person who gave it to you? Or is it before that person? Or was it 5 people before that person? You need to understand the boundaries of your problem and interactions among the parts to solve the problems. Okay, so, all right, we have a little fly going in there, a spider web. Here's another example of, is one a better example of a systems thinking example or not? So in this example, on the left, we have you, okay, a human being. And on the right side, we have all the layers of people and stakeholders on a project. And there's lots of them. We know this. Customers, regulatory agencies, sponsor, stakeholders, managers, team, and finally, you, us, right in the center of it all. So what is the better example of systems thinking? The one on the right, because it's much more complex. There's many more parts and interactions than just you. And of course, you as a human being, you are a system. I mean, we know this. We are systems. We have interacting parts. We have emergent behavior. We have all of these things. But the better example of systems thinking is really on the right. Because in this image, we have a number of different stakeholders who are influencing us and influencing each other. So it's very complex. And by naming these stakeholders who impact us in advance at the beginning of the project, we are in a position to identify how they might impact our work and what we can and should do about it. So our project teams are a system of interconnected parts. None of us are working in isolation anymore. We get our inputs into our work, we do our work, we create an output, and we pass it down the line to somebody else. Our work is continually disrupted, impacted, and influenced by others. It's unpredictable, and we adapt. It's dynamic and changing. As we know, people, quote unquote, people, are the number one reason for 99% of the issues, and we can usually trace a problem back to a person in some way, because a machine is going to do what it's designed to do. A program is going to do what it's designed to do, but that is based by a person and the requirements that they give from another person. So everything kind of is traced back to a person. It's about knowing who has an influence and an interest in the project, and we need these multiple perspectives from this big onion diagram of people, right, on our project. And each of these individual stakeholders have their own individual mental models. And that's another hallmark of a system. The mental model being beliefs and assumptions that influence the system. And the beliefs and assumptions that we have are based on our own experience and where we come from. So, true to systems thinking, small actions can have large effects. A small action might be that we forgot one of these stakeholders. We forgot the regulatory agencies. But that one person or entity, if they have a lot of influence, can derail a project. That's systems thinking at work. Here's another example for you. I think it's another obvious example. We have a graphic on the left showing all the interconnected parts to an actor. The lights, the stage help, the audience, the director. And on the right, we just have the actor. So intuitively, we know which one better represents systems thinking. Systems thinking is not about working as a sole actor. It's about how everything comes together. Lights, actors, music, director, audience, everything is connected. If the director is having a bad day, then everybody is having a bad day. If the lights are burned out, the audience is not enjoying the play, and the actors don't get applause. So negative feedback loop. In the workplace, it's not just about the information or tasks that you have to do at that moment, but where did it come from? A reliable source? Did you get that information from somebody who typically gives you reliable information? Or is it somebody you don't know yet, you haven't created that working relationship yet, and they don't quite know what you need? Do you have a common understanding about the flow and quality of information coming to you? So there are plenty of factors that impact the system and in your job. And keep that in the back of your mind when you interact with other people. And this can avoid a lot of problems and save you a lot of time on a project. We also need to think about processes in systems thinking. So when we're approaching our work or we identify a problem, we need to examine the processes associated with that task. Now, we're not just going to look at the task itself, but clearly looking at the roles and responsibilities connected to the task and identifying, are the processes organized? Are they clear? Have dependencies and assumptions been considered? What other touch points with other processes might impact what we're doing? So when we have an issue or problem, we want to make sure that we've examined our processes and find the break. And that's usually with people, maybe not understanding the process. The last piece that I want to talk about in terms of understanding systems thinking before we get into defining it and looking at the more technical aspects is about loops. So systems thinking involves both positive and negative feedback loops. With a positive feedback loop, the change is amplified. The direction of the system gets bigger, faster. And it doesn't mean good or bad. I mean, that depends on the system. But in the case of an orange ripening, the orange produces ethylene gas, which further quickens the ripening process. Okay? So this causes more ripening. It's a positive feedback loop because it's amplified and the ripening speeds up. But if you put the orange in the fridge, then the ethylene gas production, it slows down, and it slows down the ripening. This is a negative feedback loop. Negative feedback loops resist the change and try to bring a system back to a steady state by counteracting deviations. In terms of how we can use this information in our jobs, if we get dirty data and we pass it on to somebody else and they use it in 10 different places, then this dirty data is getting amplified. We have a positive feedback loop, which we need to fix. So think about these kinds of loops that you have in your job and if they need to be modulated. This concept is a little bit harder, I find, to wrap your head around and use in a practical way. But if you can identify the patterns and trends that are happening that are good or bad for you, that will help identifying what these loops are and whether they're positive or negative and what you need to do about them. So now, finally, after we've gone through all of these everyday examples, let's get to the official definition of systems thinking, because we always need to have the official definition of something. INCOSE, which is the International Council on Systems Engineering, defines systems thinking as a way of thinking that recognizes systems as wholes with interrelated parts, whose properties emerge from the interactions and relationships among those parts. Systems thinking is a mindset. It's a way of seeing, thinking, and approaching your job and your life, for that matter. It's about seeing how different parts are interconnected and interact in an organized way in terms of people, process, technology, data. And this involves considering multiple stakeholder perspectives to understand complex problems. It's not just about surface thinking. You know, we always have this picture of the iceberg, which shows the surface thinking. We need deep thinking, big picture thinking, looking beneath the surface to find the causes. So if it's at the tip of the iceberg, it's about events or visible outcomes, you know, something that's very obvious. If it's just below the surface that we're looking at patterns or trends over time. And if it's even deeper than that, I mean, that's where we're looking. We're going to uncover some issues in system structures, such as policies and processes. And in the deepest layer, so this is at the bottom of the ocean, we are looking at mental models. This is the core of a person, their beliefs, their values, and their assumptions. And that is really where you want to get to uncover some root cause and some ways to change. So let's throw this iceberg into an example. Let's suppose that defects were found in software after it was released. The tip of the iceberg would be that, well, QA didn't test very well. That's what somebody might think. Below the surface, it might be that QA didn't create the right tests or enough tests. Deeper than that is the QA team doesn't have the right team members because the hiring process is defective. Okay? And even at the deepest layer, we're going to be saying when it comes to mental models, beliefs, values, and assumptions, maybe the company doesn't value the QA team, so they're not putting a lot of focus on it. And that's why the hiring system is defective. That's why the QA didn't create the right tests or enough tests. And that's why the the testing didn't go that well and the software released had some bugs. Okay? So thinking in terms of this iceberg. And when we look at it in a different way and to formalize what systems thinking is, then it is first looking at the purpose and the function. So what is this system intended to do? What is the reason for its being? And then looking at components and parts. So you want to deconstruct the system and figure out what the components and parts are in terms of people, process, technology, and data. Then you want to understand the interconnections among these parts. What are the interfaces? How do people talk to each other? How do they communicate to each other? Are they communicating in one medium that doesn't work? Like, for example, are they sending emails when text is better? Okay, so what are the interconnections and the interfaces? The inputs and outputs. So this is the materials, energy, or information that enters and exits the system. Boundaries. We always need to know what are our boundaries around the system versus the environment in terms of people, process, technology. So where does the system start and end and affect how we define the problem? So think about the spider again. If a strand in the web breaks, is it because of web development? Is it because of the spider's skill? Or is it because of an external factor like rain? Okay? So knowing the boundaries of the system and what affects the system is really important, as well as the environment and the context, external factors that influence or interact with the system. Life cycle, we always need to know in terms of system, if it's a software system or another system, we're always paying attention to the life cycle, this concept of time, from conception and design to operation and disposal. Changes over time, rate of change, rate of decay, delays, timing, okay? And emergent behavior, okay? That's just another word for kind of new behavior. And patterns, when we think about patterns, what's happening in our job, in our project, what are the patterns that you notice in the interactions? What do we want to change or stop? And how can we? And closely tied to that is feedback loops. So where do things reinforce, amplify, or balance themselves? Like the orange. Is the orange continuing to ripen in a bad way? Or are we able to kind of stop that ripening? And of course, people and processes. I added coffee because I wanted a rectangle. Okay, so those are the key elements in systems thinking. To bring it all together, we're going to take a look at a very quick case study here that I think will bring these concepts to life. So I work for McDougall Energy as a consultant. McDougall Energy is Canada's largest privately owned energy company. And this is a company that lives by its values, by the way, if you ever want to take a look at McDougall Energy, on trust, caring, ambition, and excellence. A very good company. So I was assigned to a major ERP, Enterprise Resource Planning. It was a major system. It pulled out all the company's old business systems, tech systems, and included areas in sales, credit, accounting, service, operations, all of that. It really was about 60 projects in one. I mean, that's how big it was. There was lots of business and technological transformation. There was more than 1,500 use cases that we were dealing with, lots of user stories and requirements. There was time constraints. There was major risk on the project. It involved major transformation. And we had a large project team, over 60 people on the primary team, and 10 of those were in the project management office, which is where I was. We also had a vendor doing custom software development, okay? New ERP vendor. So these are our boundaries, kind of like the scope. And obviously, people were nervous about getting everything done. It was tough. And so We had a lot of deliverables. User stories, requirements, process maps, use cases, work instructions, training material, test cases, so many different deliverables, 1,500 use cases, thousands of requirements. It was really tough even to start thinking about it. And most of these deliverables were done by separate groups and departments in a linear way, okay? And in a consecutive way. So if we approach the project the way we normally do, all the separate groups doing their own thing, we never would have finished on time. But we looked at the similarities among the deliverables, how we could leverage one to the other, how one could be an output or an input to another to save time. So rather than having separate lines, we created a web of information and had a huge degree of collaboration among stakeholders. So obviously, this took a lot of project management skill. What happened? We completed everything on time to a great quality because we thought about the deliverables as a system, not individually done by individual team members. And this project could be completed through systems thinking and the strong support of the executives. That's how we got it done. Because of McDougall Energy values and corporate culture, we had the advantage of stakeholders and project team with a high level of knowledge. They were plugged in, eager to help, and they were invested in the future of the company. They were positive, open, and trust in the company culture. And that was a great advantage to this project, actually, is the people side was on side. So in terms of the habits of a system thinker, and I'm wrapping myself up here, is that we need to have different perspectives because that deepens understanding. We need to observe how things change over time and how those changes generate patterns and trends. We need to understand the big picture and recognize there's more than what meets the eye. I mean, look at the iceberg. And we need to have an understanding of the system's behavior to influence the change, the interconnectedness and complexity. So if you're on a project and you look at these factors, that is really going to help you save time, improve quality, and get that better job. And in terms of people, process, technology, tools, data, we always want to think about that. And because that is the cornerstone to a good project. Final thoughts, ask, what's the bigger picture? Look for patterns, not isolated events. Seek root causes, not symptoms. Think in loops and webs, not lines. Make your assumptions visible. Balance short-term and long-term effects and consider multiple perspectives. I write a lot of books. I have more coming out next year, and I am happy to connect with you on LinkedIn. Thank you.